A rifle is fired at an angle of 35 degrees relative to the horizontal at an initial velocity of 185 meters per second. It lands at the same height it was fired from. Find the range or the horizontal distance of the rifle bullet. So it was sent up or shot out at 185 meters per second, so we're going to make a velocity triangle. We have a 35-degree angle in the corner because it's 35 degrees up for the horizontal or the horizontal line. In order to calculate the horizontal velocity, it's adjacent to the angle, so we're going to use hypotenuse cosine angle. And then for the initial vertical velocity, it's on the opposite side of the angle, so we're going to use hypotenuse sine angle. 185 cosine 35 and 185 sine 35. Keep in mind that your calculator must be in degree mode. I recommend checking it before doing any set of problems. After we've got the picture satisfied, we're going to do our XY table every single time. Anytime something's moving in the horizontal and the vertical, two motions, horizontal and vertical, we're going to make the XY table. On the left, we have delta x, Vx, and t. On the right, we have delta y, V0, V, A, and t. By calculating 185 cosine 35, you put in your calculator 185 cosine 35, enter. It looks like we get 151.54 meters per second horizontal. And remember, the horizontal velocity doesn't change. It is continuous. There is no acceleration horizontally. Vertically, initially, we're going to have 185 sine 35, or 106.11 is our initial vertical velocity. It's the initial vertical because there is an acceleration from gravity pulling downward. The initial motion is up. We've identified that as positive. And since gravity pulls down, gravity will be negative, negative 10. And we need to determine the delta x. Well, in order to solve the left side, we need to have two knowns. And we do not at this time. We only have one known. So on the right side, we need to solve for time so that we can then move it to the left. Well, what else do we know on the right? Well, if it went up at 106.11 meters per second, when it comes back down at that same height, it will also be 106.11 meters per second, except for in the downward direction. In this case, downward is negative. We can use our Votat equation, v equals v0 plus acceleration times time, and then we're going to rearrange that equation as seen on the screen so that v minus v0 divided by acceleration is equal to time. Negative 106.11 minus 106.11 divided by negative 10 will get us our time. Again, that just solves for time, doesn't answer the question, but it moves us forward in answering that question. And we get the time, total time in the air, as 21.22 seconds. We can now place that on the left side of our XY table, and we're ready to solve for displacement in the x direction. Delta x is Vx times time. 151.54 times 21.22. This gets us our range or horizontal displacement or delta x. However you want to describe it, they're all the same thing. Looks like delta x is going to be 3,215.68 meters. Number 2, at a motorcycle race, a biker jumps off a ramp that has a 65-degree angle relative to the ground or relative to the horizontal at a velocity of 25 meters per second. So our hypotenuse is 25 meters per second. Each side will be a velocity because it's a velocity triangle. The angle on the left side coming off the horizontal is 65 degrees. Vx there at the bottom, because it's the adjacent side, Vx is going to be 25 cosine 65. And V0, the initial vertical velocity, would be calculated as 25 sine 65. Again, our calculators are in degree mode. After we draw the picture, we always make the XY table if the object is moving both horizontally and vertically. On the left side, we have delta x, Vx, and t. And on the right side, we have delta y, V0, V, A, and t. More on the right because there's that pesky little acceleration called gravity. Once we calculate Vx at 25 cosine 65, we can fill it in. It looks like 10.57. and then we can calculate V naught at 25 sine 65. Put that into our table. Looks like it's going to be 22.66. The initial direction is up, and we identified that as positive. So we know that gravity is down, so the initial velocity being up, positive, acceleration is from gravity down, so negative. Opposite directions. Now, the first question asks us, what maximum height above the ramp does the biker reach? At maximum height, our vertical velocity goes to 0. Total velocity doesn't go to 0. He doesn't suspend in the air. Horizontal velocity is continuous, but the vertical velocity goes to 0 as the motion goes from up to down, changing directions. Based on the variables that we have, we're going to use V naught is equal to V squared is equal to V naught squared plus 2a delta y. And on the screen, you can see how we can rearrange that equation so that it solves for delta y. V squared minus V naught squared divided by 2a, or 0 squared minus 22.66 squared divided by 2 times negative 10. Once we square the 22.66, we'll multiply by that negative out front, so we've got a negative number on the top, and then 2 times negative 10 will give us a negative 20 on the bottom. When we do the math, it looks like it gives us 25.67 meters for our delta y. B asks us, how long does it take for the biker to return to the ground? I'm going to use an XY table to solve this problem. Delta x, Vx, and t. And for y, delta y, V naught, V, A, and t. Some information we can pull down from above. We know the initial vertical velocity is in the upward direction with a positive 22.66. And since it's returning to the ground, we're looking at total time in the air. The final velocity would be negative 22.66 because he's returning to the same height from which he left the ground. Acceleration is negative 10 because it's in the opposite direction of the initial velocity. Here we can use VOTAD. V equals V naught plus A times T. The screen shows you how to rearrange it so it solves for T. We end up with negative 22.66 minus 22.66 divided by negative 10 is equal to T. Put that into a calculator, and then we can solve for total time in the air. If you interpreted this as return to the ground from the highest point, your time would just simply be half the time that I found, because I found total time. Number 3, a baseball player hits a fly ball towards center field where the fence is 165 meters away. So you see I'm drawing the 165 meters away from home plate, and it's 3 meters tall. So it's not a very tall wall relative to baseball speaking, I don't think, but there's my 3 meter tall wall. If the velocity of the baseball is 45 meters per second, and it's going up at a 29-degree angle relative to the horizontal, will the ball clear the fence for a home run? And it gives us a hint, but we're smart people, we can figure this out. But what does the hint say? Find the height of the ball at x equals 165. So really what I want to do is find out, how long does it take for the ball to reach the wall? And once I know how long it takes to get there, then I can calculate what is the vertical displacement at that moment in time. If it's less than 3 meters, I don't clear the wall. If it's more than 3 meters, I get the home run, score some runs, and win the game. We remember that the Vx in our triangle is going to be calculated as hypotenuse function angle, 45 cosine 29, giving us a 39.36 meters per second horizontally. Vertically, V naught is 45 sine 29, calculated as 21.82. Once we get those values, everything else is as it has been before the angles. We make our XY table. Delta x is 165 meters from the problem. Vx from our calculation is 39.36. Time we don't know yet. Delta y, that's what we really want to know. Initial velocity upwards is 21.82. Final velocity, don't really know yet at that moment in time, but acceleration is negative 10 because it's in the opposite direction, it's downward, and time we don't know. Now we're going to calculate delta y. Don't be tempted to put a 3 meters at that moment because we don't know the ball is at 3 meters. That's just the height of the wall. So we're going to compare that value to the 3 meter tall wall. So first let's find out, how long does it take to reach the wall? Well, if you're going to move 165 meters from left to right, and from left to right you're moving at 39.6 meters, we're just going to take our delta x is equal to vx times t and rearrange it so that we're solving for time. Delta x divided by vx, or 165 divided by 39.36, is our time. Once we calculate that, we can put time into our table on both sides. Looks like we're getting about 4.19 seconds for our time, so we can put in 4.19 on both sides if we wish, and that gives us the time that the ball will arrive at the 165 meter range. Now we just need to know, well, what's its height at that moment in time? We want to solve for delta y. Well, if we have v naught a and t, and we're looking for delta y, we can use the delta y is equal to v naught t plus 1/2 a t squared. So delta y is equal to v naught t, 21.82 times 4.19, plus 1/2 of negative 10 times 4.19 squared. So I'm going to take the 21.82 times 4.19, just kind of simplify it as I'm going along. So if I round here and you carry it all the way down, our numbers might be slightly different, but not by a lot. Once we run these through the calculator, we get 91.43. And then I put minus because I know it's going to be 1/2 times negative 10. So I know I'm going to be subtracting this number. That number is going to be negative. So I've got 4.19 squared times essentially 5, because 1/2 of 10. I get 87.78. Then I'm just going to combine those numbers. I've got 91.43 minus 87.78. 3.65 meters. So our height is 3.65 meters. The fence is only 3. So yes, it looks like we're hitting that home run. Our ball is going to go up and over the fence like I just showed in the diagram. Yes, we've hit the home run. We get the runs on the board. We get more points than the opposition, and we win the game. So yes, victory. Number 4, a cannon is fired at an angle of 85 degrees relative to the horizontal. If the cannonball has an initial velocity of 508 meters per second, how far horizontally does the ball travel? So we have a velocity of 508 meters per second going up at an 85 degree from horizontal, and we just need to first calculate what are the components. What is the horizontal component and what is the vertical component? 508 cosine 85 from the hypotenuse function angle, and v naught, the initial vertical velocity, would be 508 sine 85 from the hypotenuse function angle. V naught is on the opposite side, so it uses sine. Vx is on the same side. It's adjacent to the angle, so it uses cosine. After we get our picture satisfied, we're going to go ahead and fill in our xy table. Every single time we do our xy table, we have delta x on the left, Vx on the left, and time on the left. We can go ahead and fill in our Vx because we know how to calculate that. 508 cosine 85, enter in our calculator in degree mode, gives us 44.28. On the right side, because we have acceleration, we'll have a few other variables because there's that change of velocity due to gravity. On the right, we have delta y, the displacement, the initial velocity 506.07 from the 508 sine 85. Final velocity we don't know just yet, depending on the circumstances. And then we've got acceleration at negative 10. Now in this case, the cannonball, it's going to travel and land at the original position, so we can say that the final velocity is negative 506.07, same as the initial, but opposite direction. Here we're going to solve for time so that we can solve for delta x. We're going to use VOTAT to solve for time. V equals V naught plus A times t, rearranged on the screen for you. That gives you the final velocity, negative 506.07 minus 506.07 divided by the acceleration, negative 10. Looks like the total time is going to be 101.21 seconds. That's how long it's in the air. Total time in the air. Well, if the total time in the air is 101.21 and it's traveling at 44.28, how far horizontally does the ball travel? Delta x is equal to Vx times t. on the left side? That comes from delta x is equal to v naught t plus 1/2 at squared. Well, a is 0, so 1/2 at squared is 0, so you're left with displacement is equal to velocity times time, or 44.28 times 101.21. So delta x would be equal to 4,481.58 meters.